Hello everyone. In tonight's video that I promised you, I will show you how we can measure transistors with a multimeter and how we can find their legs based on collector-emitter. Very easily with a simple method. To see this, first of all, let's see how transistors are structured from the inside internally. Transistors are basically made up from two diodes which have a common leg, either the anode or the cathode. I will make one here now. I will make a 2 here pin and an EP. I didn't make it black, I made it pink instead, so we have the three legs of the transistor. This is this and this. We have pi and pi. The aura was not black tiger. The pi and pi transceiver is the structure from within two diodes, one looking at the other, the negative in the middle, and its little feet go collector base emitter, so it's the transistor P and N. With the little legs collected according to the emitter. And now I will draw outside Bj blast brows according to the emitter blasts. And now I will draw an NPN transistor how it is from the inside. It's exactly the same as the diodes backwards. We will first do the N, then the P, the diodes, then continue again with P and N. Great. And in the middle, the base is positive. So here we have the NPN transistor, it's N here, and the P in the middle, which is the base. Again, the same little legs, and this, collector in the first, base in the second, and the third button. Not all transistors have their legs like that, meaning the base is always in the middle, the button on the right. We will see how we can find them with the multimeter. How do we do it? How do the legs go on a transistor up? We will deal with a germanium transistor again, so we expect 500 to 600. I will show you, here I have two little transistors, and I will show you how we can find out if it is PNP or NPN and where the base, collector, and emitter are. Initially, looking for where the leg is, we find the base, we try to correctly develop the NPN and PNP. Depending on the transistor, and with the help of the multimeter, it will show us how to correctly develop and how to find the base, collector, and emitter. At this point, I will say that between the collector and the base, we have greater conductivity than between the base and the emitter. So let's keep in mind that between the base and the emitter, there is also a resistance that increases our conductivity because the base collector has lower conductivity. We will design a resistor on the base with the emitter so that we can easily find the terminals on the transistor afterwards. So let's suggest that we have a resistor here between the base and the emitter in the PNP and NPN the same. It can be done. The base with the emitter is here, so we will also place a resistor here, and we will now start taking measurements on the base of this circuit that we have created over here. The red on the P always and the black on the N, that's what we are looking to find, the forward bias, whether it is PNP or NPN. This is the forward bias, and with the difference that at the emitter base we will have a voltage drop and resistors. So let's see it in practice now. Here we have two transistors, which we do not know if they are NP and PNP nor how the legs go. We have two transistors, and our multimeter, the diode meter. I will now show you what measurements we will take to find the legs and if the transistor is NP and PNP. So let's begin. We are looking to first find the base. So we will make combinations on our multimeter, on the terminals, on the legs, until we find an indication. Any indication will show us. So I start by measuring the legs. I measure middle to end to middle. I search to find an indication. Any. We have our first clue. Now the base is the middle or the right, so we keep the terminal steady. Anyway, we still don't know where the base is. I hold the outer, the black, steady and move the red to the edge. I have no clue. So the base is probably most likely in the middle. So I measure middle here again. It shows to my right, and inside it shows to my left again. 657 and 658. You see here. So surely with what we are doing, we found that our base is in the middle. And since we have the red terminal in the middle, it means that our base is the pi in pi, that is, we are in NPN. Since our base is P, we have found that the base is in the middle so far, and that our organization is NPN. With this measurement, now we are looking to find the collector. We said the collector has higher conductivity, so lower resistance and lower voltage drop. If the emitter has a higher voltage drop, then the large number will be at the emitter and the small number will be at the collector. So here we have X58 with the resistance X58. And here we have X56 smaller, so here we understand that the collector is on the left because we have a smaller voltage drop, so it's a collector, and the printed one is the emitter. And so we found in the transistor and its legs, and that it is NPN. We just have to keep in mind we said the above plan with the diodes and a resistor that exists between the base and the emitter. Well, let's also look at the second transistor. We don't know what this is either. I will start taking measurements again to search and find the base. Well, here it shows nothing. Here is nothing. Here I have a clue. So here is nothing. I have a clue here, and over here is the base. And it is black in the middle, the black terminal. So we have here in the middle where the base is, so our inside is PNP. Well, we found the base. I leave the black on the base and start to find where I have a greater voltage drop. Here I have 634, here I have 636. So from this side, X36 is greater, so here where I have a greater voltage drop is the button here. It's the collector, that is. I'm counting. And on the other side, I have a greater voltage drop. It's the button. We have found again that they are compared little currents in the collector of the base that can lift its little feet in our PNP. Just like that, if we try other little currents, we will see that if we do more tests, it will be easier to find them and faster. The more you try, the more you will understand. the faster you will find the legs and the base. Of course, we can take these measurements. And on the transistor circuit, if the transistor is connected to a circuit, up and down will show the same indications. In some cases, they are connected. Parallel resistors and such, which have some changes in our measurements. But we understand more or less if the transistor is correct, if it is short-circuited, and then if we have any suspicion, we disconnect it and measure it exactly like this. There is no way we will make these measurements to be misled by the tracer. That was our video for today. For those who liked it, we give a like, we share it, so that as many people as possible can see it. And until the next video, have a good time. Hello to everyone.